Let's practice writing some prime factorizations together. So for number 1, we have this number 12, and so we're going to go ahead and write 12 at the top and think of two numbers that multiply to get to 12. First thing that comes to mind for me is going to be 3 times 4, and we go ahead and circle any prime number. So 3 is a prime number, but 4 is composite, so break 4 down into 2 times 2, and 2 is going to be prime, so I'm going to go ahead and circle those. And so if we're going to write the prime factorization for 12, it's going to be 2 times 2 times 3. And using exponents, we can say this is 2 to the second power because there's two 2's, times 3 to the first power because there's only one 3. Okay. For number 2, we have the number 15. 15 can break into 3 times 5. Okay. 3 happens to be prime and 5 also happens to be prime. So we can write the prime factorization for 15 is going to be 3 times 5. Using exponents, it's not really going to change, but we have one of these 3's and we have one of these 5's. Okay. For number 3, we have the number 20. So 20 we can break down into, I'm thinking 10 times 2. 2 is going to be our prime number here, we can circle, but 10 is composite, so 10 can break down into 2 times 5. And then go ahead and circle this 2 that's prime and 5 that's also prime. So the prime factorization for 20 is going to be 2 times 2 times 5. And using exponents, we can say that's 2 to the second power, and then that's 5 to the first power. Let's move down and try number 4 here. For number 4, we have the number 18. So for 18, I'm going to start by writing the number. Thinking 3 times 6 is going to be 18. 6 is composite, but 3 is prime, so I'm going to circle it. And 6 breaks into 3 times 2. And those are both going to be prime numbers, so I'm going to circle those. Okay. The prime factorization for 18 is just going to be 2 times 3 times 3. Using exponents, we can say there's 1, 2, and there are 2 of these 3. So 2 to the first power times 3 to the second power. For number 5, we have the number 20. All right, so this hopefully makes sense. We can go ahead and take the 5 and a 4. 5's prime, I'm going to go ahead and circle that one. And 4 is composite. I'm going to break that down into a 2 times 2. Again, 2's are prime, so I'm going to go ahead and circle them. And so the prime factorization here is going to be 2 times 2 times 5. Also known as 2 to the second power times 5 to the first power. For number 6, we have the number 27. So 27, we can break that down. I'm thinking 3 times 9. And 3 is definitely a prime number, so I'm going to circle it. But 9 is composite, so I'm going to break 9 into 3 times 3. And again, these 3's are prime, so I'm going to go ahead and circle them. The prime factorization for 27 is going to be 3 times 3 times 3. And using exponents, we can just say this is 3 to the third power. Okay. For number 7, let's go ahead and see that one. We have the number 30. So I'm going to go ahead and start by writing the number 30 down and think of two factors. I'm thinking maybe 5 times 6 is 30. 5 is prime, so I'm going to go ahead and circle the 5 and break down the 6 into 3 times 2. Okay. 3's are prime and so are 2's. So the prime factorization here we can write for 30 is 2 times 3 times 5. And using exponents, there's only one of these 2's, there's only one of these 3's, and there's only one of these 5's. Okay. For number 8, we have the number 45. And we can break 45 down into 5 times 9. 5 times 9 is 45. 5 is prime, so I'm going to encircle it. And 9 is composite. It breaks down into 3 times 3. We can go ahead and circle those 3's here. And we can say the prime factorization for 45 is going to be 3 times 3 times 5. And using exponents, we can say that's 3 to the second power times 5 to the first power. Here's number 9. Number 9, we have the number 11. So we're going to go ahead and write the prime factorization for 11. Keep in mind that we actually can't write any other factors besides 1 times 11. And our factor trees only have prime and composite numbers, not ones. So we're just going to go ahead and say that the prime factorization for 11 is just 11. And there's really just one 11, so 11 to the first power. Okay, so it's a prime number, so the prime factorization for 11 is just 11. Then we have the number 28, and so I'm thinking maybe 7 times 4, that's going to be 28. 7 is prime, I'm going to circle it, and if I bring down this 4 is going to break into 2 times 2. And those are both prime numbers, so I'm going to go ahead and circle the 2 and circle the other 2. So the prime factorization for 28 we're going to get is going to be 2 times 2 times 7. And using exponents, that's 2 to the second power times 7 to the first power. For number 11, we have the number 35. So 35, I'm thinking 7 times 5 is 35. And I think those are both prime, so I'm going to go ahead and circle both of those. So the prime factorization for 35 is just 7 times 5, using exponents just 1517. For number 12, we have the number 48. Let's give that a try, 48. Let's see here, I'm going to go with 6 times 8 is 48. 6 breaks into 3 times 2. Those are going to be both prime numbers. Now for this 8, 8 breaks into 2 times 4, and 2 is prime. And then we can break this 4 down and say this 4 can break into 2 times 2. And so we have 2 more prime numbers down at the bottom here. So the prime factorization for 48 is going to be, let's see here, it's going to be 2 times 2 times 2 times 2 times 3. Lots of 2's, okay? Using exponents, we can say this is 2 to the 4th power times 3 to the 1st power. Okay. For number 13, we have the number 36. So 36, I'm going to start with 4 times 9. That's the first thing that comes to mind to me. These are both composite numbers, so we can keep going. 4 breaks into 2 times 2. And of course, 2's are prime, so we're going to circle them. And 9 is going to break down into 3 times 3. And those are both prime as well. So we have a 3 and a 3 here. So our prime factorization for 36 we can write is 2 times 2 times 3 times 3, also known as 2 to the 2nd power times 3 to the 2nd power. For number 14, we have the number 24. So we're going to take that 24 and break it into, I'm thinking 3 times 8 is 24, and 3 is going to be prime. And this 8 can be broken down into 4 times 2. And this 2 is prime, so let's go ahead and circle that. And then finally, this 4 is composite and it breaks into 2 times 2. And these 2's are prime as well. So 24's prime factorization is going to be 2 times 2 times 2 times 3, also known as 2 to the 3rd power times 3 to the 1st power. Let's try number 15. For number 15, we have the number 32. So for 32, let's go ahead and write that. And I'm thinking, what times what is 32? I'm going to go with 8 and 4. So I do 8 times 4. And I think 8 is going to be broken down into 2 times 4. And 2 is going to be prime, but 4 can be broken down. So this 4 can be broken down into a 2 and a 2. Those are both prime. And this 4 up here can also be broken down into a 2 and a 2. And so we have lots of 2's for the number 32. All right, so we have 1, 2, 3, 4, and 5 2's. Using exponents, we can say that this is 2 to the 5th power. Finally, we have one more on this page, and that's going to be the number 72. So let's see if I can fit this in here. 72 is going to be, I'm thinking 8 times 9. And 9 breaks into 3 times 3, and those are both prime. Go ahead and circle the 3's. For the 8, I'm thinking maybe 2 and 4. And 2 is going to be prime. And this 4 can be broken down into 2 times 2. So we have a bunch of 2's and 3's for 72. So it looks like we have 3 2's, so 2, 2, 2. And we have 2 3's. Using exponents, we can say this is 2 to the 3rd power times 3 to the 2nd power. Moving on to number 17. For 17, we have the number 49. So let's take 49 and break it down. The only thing I can think of is 7 times 7. And that's 49. And 7's prime, so we're actually done there, right? So the prime factorization is just 7 times 7. And using exponents, we can say that's 7 to the 2nd power. For number 18, we have the number 51. So 51 we'll start with. If you're trying to think of something it's divisible by, remember you can add 5 plus 1 is 6. So you know if 6 is a multiple of 3, then you can divide this by 3. Turns out 3 times 17 is going to be equal to 51. 3 is prime, and so is 17. So the prime factorization is going to be 3 times 17. Or we can say that there are 1 3's and 1 of the 17's. Okay. For number 19, we have the number 47. So 47, if you think for a moment, it's not divisible by 2, not divisible by 3, because 4 plus 7 is 11. Can't think of anything it's divisible by, so actually 47 is a prime number. You should go think about what it might be divisible by, but I'm telling you right now, it is prime. So there's just one 47, that's it. For number 20, we have the number 60. The first thing that comes into mind is going to be 6 times 10. They're both composite, so 6 will break down further into 2 times 3. Both prime numbers, so I'm going to go ahead and circle those. And 10 is going to break into 5 times 2. And those are both prime as well, so I'm going to go ahead and circle those. Prime factorization for 60 is going to be 2 times 2 times 3 times 5. And that's also known as 2 to the second power times 3 to the first power times 5 to the first power. For number 21, we have the number 80. Just like 60, I'm going to use 10 because I think that's easy. So 10 times 8 is 80. And then 10 can break into 5 times 2. I'm going to go ahead and circle the 5 and the 2. This 8 I'm going to break into 2 and 4. And this 2 is going to be prime. And this 4 can break down further into a 2 times 2. And so those are going to be prime numbers as well. So finally we have, it looks like 4 2s, 1, 2, 3, 4, and then a 5. And so using exponents, we can say this is 2 to the 4th power times 1 5. Okay. For 22, we have the number 75. So for 75, I'm thinking it's divisible by 25. So 3 times 25 is 75. 3 is prime. And 25 breaks into 5 times 5. I'm going to go ahead and circle those two 5s to make 25. So the prime factorization I'm getting here is going to be 3 times 5 times 5. And we can rewrite this as 1 3 times 2 of these 5s. For number 23, we have the number 100, and I'm going to go ahead and break that down into 10 times 10. And 10 will break down into 2 times 5. Those are both prime factors. And then I'm going to take this 10 over here, do the same thing, and say that's going to be 2 times 5. So we have these prime factors, and I'm going to say this is going to be 2 times 2 times 5 times 5. This is also known as 2 to the second power times 5 to the second power. For 24, we have the number 23, and so think about all your factors and your divisibility rules, but if you can't think about anything, that's because it is prime. So the prime factorization for 23 is just 23, or 23 to the first power. Let's check out the last few here up to 25. We have the number 16, so I'm going to go ahead and write 16. And thinking 2 times 8. 2 times 8 is going to be 16. 2 is prime. 8 can break down into 2 times 4. Again, this 2 is going to be prime, and this 4 can be broken down a little further into 2 times 2. And so I think we are now done. 16 is the same thing as 2 times 2 times 2 times 2, also known as 2 to the 4th power. For 26, we have the number 39. And if you think it's prime, think again. 3 plus 9 is 12, and so 12 is a multiple of 3. So you can divide this by 3. Turns out it's 3 times 13. 3 times 13 does equal 39, and these are both prime factors. So we have 3 times 13, or we are saying that there are 1 of these 3s and there are 1 of these 13s. Okay. For 96, this next number, a pretty big number, but I think it's even, right? So we can divide it by 2. 2 times 48 is 96. And so we can go ahead and circle that 2. Again, it's an even number, so we know we can divide it by 2. For 48, I'm going to say 24 times 2 is 48. And so 2 is prime. 24 we can break into 3 times 8. And I'm going to circle the 3. 8's going to break into 2 times 4. I'm going to go ahead and circle that 2. And this 4 we can break down just a little bit more, and I'm going to say that's going to be a 2 and a 2. And I think we have all our prime factors now. So for 96, we have, I think, 5 2s, 1, 2, 3, 4, 5, and 1, 3. And using exponents, we can say there are 5 of these 2s multiplied by 1 of these 3s to get 96. Moving on down to number 28. For 28, let's see what we got here. We have the number 120. So for 120, this is a pretty big number here. I think we can fit it with all the rest of these. So I'm thinking 10 times 12 would be 120. 10 we can break into 2 and 5. Those are both prime. I'm going to go ahead and circle those. 12, I'm thinking maybe 2 and 6. And 2 is prime. And 6, I'm thinking 3 and 2. gonna go ahead and circle that 3 and circle that 2. And so for 120, it looks like we have a 2, a 2, a 2, a 3, and a 5. And so basically using exponents, we can say there are 3 of these 2's multiplied by 1, 3, and 1, 5. For number 29, we have the number 144, so I'm gonna go ahead and put that a little bit over here. For 144, I think a common thing people think of more so than others is probably 12 times 12. 12, I'm thinking 6 times 2. 2 is going to be prime, and so I'm gonna go ahead and circle that, and the 6 here we can break into a 3 and a 2 while we're at it. And so that's going to be our prime factors as well. Over here to the left, I'm gonna do the same thing. I'm gonna do 2 and 6. And circle that 2, and the 6 we can break down into 3 and 2. And I'm gonna circle those as well. So it looks like we have 1, 2, 3, 4 2's. So I'm gonna go ahead and say we have 1, 2, 3, 4 2's, and we have 2 3's. So altogether, it's gonna be 2 to the 4th power times 3 to the 2nd power. Okay. For number 30, we have the number 64. So for 64, let's see here. I think we're gonna have, what am I gonna start with here? I'm gonna start with 2 times 32, okay? And the 32 can be broken down more. Let's say that we can write 2 times 16. And then 16 we can break into, 4 times 4. And 4 can be broken down into 2 times 2, and this 4 can be broken down into 2 times 2. So we have a lot of 2's here. 1, 2, 3, 4, 5, 6. So I'm gonna go ahead and just write this using exponents because I'm running out of space here. This is 2 to the 6th power. You could write 2 multiplied by itself 6 times as well. Okay. For number 31, we have the number 77. So for 77, I'm going to break that into, I think, 7 times 11. And I think it's a pretty short tree. All right, it's just 7's prime and 11's prime. So we have 7 times 11. And using exponents, that's just 1 7 multiplied by 1 11. Okay, moving down to this last one, number 63. 63, I'm thinking we can break into 7 times 9. And keep in mind, 7 is prime, but 9 is not. 9 can break down into 3 times 3. And so what we're going to have here is going to be the prime factorization is 3 times 3 times 7, also known as 2 3's multiplied by 1 7. So there you have 32 different practice problems of finding prime factorizations using factor trees. And hopefully you found it helpful and you feel a little bit more comfortable with it.